Hi guys, I've missed you all. I'm really glad that we're going to start our distance learning. So as we kind of get into that, I just wanted to make a few announcements. So first thing, as you're going through the video, make sure that if there's something that you're not understanding, that you pause it and rewatch it. Listen back to what I was saying. Maybe stop writing and just listen. And then also, if there's still a question that's bothering you, whether it's from the homework or from the review or whatever it is, make sure that you post it to Google Classroom. That way that I'll be able to go and look at those questions, and I'll kind of be ready to answer those when we have our Zoom office hours. All right, so I'm going to start off with the Unit 7 Solving Quadratics test review. So remember, we were supposed to have this test right before we left, and unfortunately, or right after we left, I should say, the week after, and unfortunately we won't be able to assess in class. So what we'll be doing is we'll be assessing you at home. Now this assessment, right, this is for our data collection. We need to know what you're understanding and what you're not, so that I can reteach what you're not understanding. We also need to make sure that you're prepared for Integrated 3 next year. And so if you're not doing well on this assessment, that tells us, me, you, and your parent, that you need to recover these topics. And although it is an assessment, it will not be weighted as heavily as a normal test because I can't monitor you as closely as I could in class. So if you have any questions about that, you can email me and I'll talk to you about those a little bit more in depth. All right, so we're on the Math 2 Unit 7 Solving Quadratics test review. Question 1. What are we solving for when we solve quadratics? They have 3 names. And so those 3 names, right, we are looking for solutions. They could be real or imaginary. Those things are also called roots, and they're also called zeros. Now, if they're real, then there's another name for them, and they're called x-intercepts. And so again, if they're real solutions, these, right, would be my x-intercepts, also known as a root or zero. All right. Okay. Next question. There are different methods to solving a quadratic. Name them. There's actually 5 methods, but there's 4 methods that we use to solve, right? There's graphing, which is not really one of the methods that we use to solve because it's too time consuming. But the other 4 methods are, number 1, you can solve by, I hope you know them, factoring. 2, that only works sometimes though, remember. Square root method. Again, square root method only works in a couple cases. You either have to have it in completed square form, or the b term has to be missing. The third method is completing the square. And then the fourth method is the quadratic formula. Now these two, right, these two work for any case, but this one is difficult if a is not 1, right? So if a is not 1, I don't like to use completing the square. I like to try factoring first if I notice it's easily factorable, and then if I don't, I go right to the quadratic formula. Okay, next, what is a discriminant? So a discriminant is the portion of the quadratic formula that is underneath the radical. So remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, what you should notice is that this portion being under a radical, that gives us a little bit of information. The discriminant tells us what kind and how many solutions we have. So for example, right, if this part, b squared minus 4ac, if b squared minus 4ac is negative, well then when we take the square root of a negative number, we're going to get plus or minus an imaginary number. So that means we'll have two imaginary solutions. Now, if this portion, right, under the radical is positive, then we're going to have a number plus or minus a positive square root, which will mean that we'll get two real numbers or two real solutions. But if this value under the radical happens to be 0, which is the rarest case, if we take the square root of 0, we get 0, and if I add or subtract 0 to this number, I'll have the same value. It doesn't matter if I add or subtract it. So if b squared minus 4ac equals 0, we have one real solution. And actually, look, I just answered the next three questions. So the next question says, describe the type of solutions if this, which is called the discriminant, is negative or less than 0. Well, then we would have two imaginary solutions. And what that means when we describe the graph, describe the type of solutions, describe the graph, well, then our graph will not cross the x-axis. So graph does not cross the x-axis. All right, describe the type of solutions if b squared minus 4ac equals 0. Well, that's this case, right? And so we would have one real solution. And what that would look like is that the graph would come down and bounce off, so it just touches in one spot, or it could come up and bounce off. So again, it just touches and bounces off. So the graph bounces off the x-axis. And then finally, the last case, which is if describe the type of solutions if b squared minus 4ac is positive, well, then we'll have two real solutions. And what will happen is the graph will do something like this. It'll cross through, and we'll have 1, 2 solutions. And it could also be downward facing. And so the graph crosses the x-axis in two places. All right, I'm just going to double check that you guys can still see my paper. It's a little off. Sorry about that. Okay. Describe the solution of a system of equations. And what does the solution or solutions mean? All right, so a solution to a system means more than one equation. So you could have, for example, a line doing something like this. And you could have a parabola that's doing something like that. And so this graph, we would say it has two solutions, one right here and one right here. There could be one solution, there could be no solutions. Imagine if instead I gave you this line and this parabola. There's no solution in this case. So the solutions are where the two graphs intersect or cross. Now, the solutions will also make both equations true. So when I substitute in, for example, if I have an equation and I substitute the value in, so when I sub x comma y into both equations, the equations are true. So you'll get something like 3 equals 3. But if you were to sub in a value and you got something like 3 equals -4, no, it does not. So that would have not worked, that point that you plugged in. Okay. Next, if we solve an equation by completing the square, what number must we add to both sides of the equation to create a perfect square trinomial? So remember that to make a perfect square trinomial, the first thing we need to do is we're going to move that 72 over, our C term. And so we get x squared minus 14x equals 72. And then we would take our b, our x's, right? And we're dividing those into two pieces because we want a perfect square. Like if you can think of a little Punnett square, I would want -7x's here and I'd want -7x's here. And then when I multiply those back, I would get 49. And so I take my x terms, I divide them by 2, -14 divided by 2, and then I square it. So that gives me 7 squared, which is 49. And so then I would add 49 to both sides. All right, so 72 plus 49 is 121. Awesome, perfect square. So that'll be nice. So this side's 121. And then remember our next step after we add that value to both sides is we're going to factor this side. And so we need something that will multiply, right, x times x, multiply to 49 and add to -14, which is -7. Or you could skip this step and go directly to, I'm going to get out a piece of scratch paper because I'm out of room. Go directly to this step, which is that we've just created a perfect square trinomial. And a perfect square trinomial, a squared minus 2ab plus b squared, always factors as a minus b squared. And that equals 121. And then from this point, after you have it written like this, or x minus 7 times x minus 7 is x minus 7 squared, now you're square rooting both sides. You're going to solve by the square root method. So you get x minus 7, right, these reduce, equals, don't forget your plus and minus. The square root of 121 is 11. And now we're going to split. We're going to say x minus 7 equals positive 11, and x minus 7 equals negative 11. And so we add 7 to each side, and we get x equals 18, and x equals -4. Now, if I substitute these values into the original equation, I get x squared, so 18 squared, minus 14x, minus 72 equals 0. So first I'm checking x equals 18. 18 squared is 324. Minus 14 times 18 is 252. Minus 72, and we're checking, does that equal 0? 324 minus 252 minus 72 equals 0. Then we would want to check the other value, this one, x equals -4. So check x equals -4. -4 squared minus 14 times -4 minus 72 equals 0. That's 16 plus 4 times 14, which is 56, minus 72 equals 0. 16 plus 56 minus 72 equals 0. 0 equals 0, check. And so both solutions work. Okay, without solving, use the discriminant to determine the types of solutions. So remember that the discriminant is, the discriminant is b squared minus 4ac. And so what happens is if this is positive, we'll have 2 real, negative, we'll have 2 imaginary, and 0 will have 1 real. So we're going to identify b and a and c. Here, a is 9, b is -6, and c is 1. And I'm going to substitute them in to b squared minus 4ac. So that's -6 squared minus 4ac. So that's 36 minus 4 times 9 is 36, times 1 is 36, and this will equal 0. Since this equals 0, there's one real solution. All right, the next one, B. Identify A, B, and C. A is 4, B is -4, and C is 5. And we're going to substitute them into b squared minus 4ac. So b squared minus 4ac. That's 16 minus 16 times 5 is 80. That's negative, oh, I have to do some mental math, 64. All right, since this is a negative, we have 2 imaginary solutions. And then the last one is A equals 2, B equals -6, and C equals -1. B squared minus 4ac. So that's 36 minus, okay, well, 4 times 2 is 8. -8 times -1, which is 36 plus 8, which is 44. Since this is positive, I have 2 real solutions. All right, I'm just going to triple check the camera. Hang on. Okay, last one. Bunch of different solving. So I'm going to get out another sheet of paper because I have a feeling I'm going to need more room. Okay, the first one, A. I look at it before I start, right? Because remember, I have those 4 methods to pick from. And since my B term is missing, I think I would choose to use the square root method. And so I'm going to use the square root method. 7p squared minus 2 equals 0. So the square root method, we move everything to the other side. So I'll add 2. I get 7p squared equals 2. And then I'll divide by 7. P squared equals 2 over 7. And now that I have p isolated, I need to square root it. So I square root both sides. P equals, don't forget, plus and minus the square root of 2 over the square root of 7. And then we do have to rationalize our denominator here. Remember, we're not allowed to have a square root 7 in the denominator, so we'll multiply both the top and bottom by a square root of 7. We get plus or minus, that'd be square root 14. Square root 14 over the square root of 49, which is 7. So plus or minus square root 14 over 7. And remember, you cannot reduce into a radical from outside a radical. Number 3b, so this was A. Here's B. This one, I would not want to use the square root method. So, and I don't want to use completing the square because A is not 1. So I think I'll try factoring. But remember that the only method where I don't need a 0 over here, or don't need a 0 right here, is the square root method. The square root method, I can have it a number over here, but every other method I have to have it set equal to 0. So I need to move the 4 back over. So I get 3q squared minus 4q minus 4 equals 0. I'm going to try factoring. Let's see. I need something that multiplies to a times c, which is -12, right? A times c, and adds to b, which is -4. And, oh, I know the two numbers, -6 times 2. and negative 6 plus 2. There they are. Okay, now, since A is not 1, right, A is 3, we have to use factor by grouping. Okay, so factor by grouping, first step, I'm going to split this into these two numbers right here. So 3q squared, this will be negative 6q plus 2q, and then minus 4 equals 0. So again, you split this term into these two numbers. All right, then we're going to split it in half and take out the greatest common factor of each side. So what do these have in common? They have a 3 and a q in common. If I take a 3q out here, I would need to have a q so that when I multiply, I get this back. And here I need a minus 2 so that when I multiply, I get negative 6q back. Always bring this sign straight down. And then we look and see what these two have in common, which is a 2. So I'm going to take a 2 out. And to get this back, I need a q and a minus 2. Because 2 times q is 2q, and 2 times negative 2 is 4. Negative 4. All right, now we're going to split it again. And what I see is my parentheses matched. Right, so they have a common factor. Again, this term and this term have a common factor of q minus 2. To get this term back, I'd need a 3q. And to get this term back, I'd need a 2. Now, remember, I'm solving. So if they just wanted me to factor, boom, I'm done. But since I'm solving, I'm going to have to set each factor equal to 0. So q minus 2 equals 0, and 3q plus 2 equals 0. Q equals 2, add 2 to both sides. 3q equals negative 2, divide by 3, q equals negative 2 over 3. Now, if I substitute these values back, they should both work. And if they don't, I've done something wrong. All right, let's look at the next one. All right, the next one, in my head, I'm kind of doing a check. Is there anything that I'm trying to factor this? I can't use the square root method, and a isn't 1, so I don't want to use complete the square. So in my head, I'm thinking, does anything multiply to 20 and add to negative 4? And I can't think of any two numbers that do that. So on this one, I'm going to use the quadratic formula. All right, so A is 4, B is negative 4, and C is 5. X equals negative B, so that becomes positive 4. Negative 4 is 4, plus or minus B squared. Don't forget, when you square a negative, it becomes positive, so that's 16, minus 4 times A times C. And then all over 2 times A, which is 8, 2 times 4. So X equals 4 plus or minus the square root of 16. Now, 16 minus 4 times 4 is 16, and then times 5 in just a second, all over 8. X equals 4 plus or minus the square root of 16 minus 80, all over 8. 16 minus 80 is negative 64. So X equals 4 plus or minus the square root of negative 64 over 8. At this point, we can see we have imaginary solutions. So when we take the square root of negative 64, it is the square root of 64 times the square root of negative 1. The square root of 64 is 8, right, plus or minus, and the square root of negative 1 is I. So we're going to have X equals 4 plus or minus 8I over 8. Now, if all of these numbers have something in common, which they do, they have a 4 in common, then you can reduce them all by a factor of 4. So that'll be a 1, that'll be a 2, and that'll be a 2. And so my solutions are 1 plus or minus 2I over 2. All right, number 5, again, I'm going to grab this sheet of paper that I was using earlier. Number 3D, I should say. So D, 4s squared plus 8s minus 12 equals 0. I noticed right away that they all have a factor of 4 in common, so I'm going to take that factor of 4 out. Now, if you don't do that, you won't miss the problem. It'll still be correct. It'll just be larger numbers that you're working with. So I'm going to go ahead and divide every term by 4. And now I can do that when I'm solving because I can divide the other side of my equation. But if I was factoring, I would leave the 4 sitting out front, right? Like 4 and then this. But since I'm solving, right, at this point, I could go ahead and divide the 4 anyway. And so I would have left s squared plus 2s minus 3. And now I can either use the quadratic formula or factoring, and I'm looking, does anything multiply to 3 and add to 2? And there is. Things that will multiply to negative 3 but add to 2 would be 3 times negative 1, because 3 minus 1 is 2. So I'm going to use factoring. And this time, since there's no leading coefficient, right, we have s squared plus 2s minus 3 equals 0, I can just factor the fast way. If I had a was something else other than 1, I would have to factor by grouping, but I don't. So s times s, and then my two numbers are right here, plus 3 and minus 1. Set each one equal to 0, s plus 3 equals 0, s minus 1 equals 0, and so we get s equals negative 3 and s equals positive 1. All right, number 3e. Number 3e is t squared minus 10t equals 24. Again, I'm not going to use the square root method. But since a is 1 and b is even, I think I'm going to use complete the square. So I'm going to do complete the square. So what I noticed is they had already moved c for me. And this is 1, a is 1, and b is even. So I think complete the square will be the fastest method for me. So when you complete the square, the first thing is to move this, but they've already done it, which is why I'm picking this method. And the next thing is you take b over 2 and you square it, which is negative 5 squared, which is 25. And that's what we would add to both sides. So I have t squared minus 10t. I'm going to add 25 equals 24 plus 25. Right? I add 25 to both sides. And now I'm going to factor this side. It factors as t minus 5 squared, right? Because I would have t minus 5 times t minus 5 to get something that multiplies to 25 and adds to negative 10. But I'm moving along, I'm skipping, and that equals 49. And now you can see it's going to be a nice perfect square. So I would square root both sides. The square and the square root would cancel. I'd have t minus 5 equals plus or minus 7. And then at this point, I would go ahead and move the 5 over, but I'm going to break it into 2. So t minus 5 equals 7, and t minus 5 equals negative 7. Move that 5, I get t equals 12, and move that 5, I get t equals negative 2. And there are my two solutions. All right, hold on one moment. I'm going to grab another piece of scratch paper as I need a little more room for this last problem. Oh, there's actually two more, but only one more solving. So I've got 0 equals negative, this is F, not E, sorry. Negative m squared plus 10m plus 5. Let me make sure you guys can see my paper. There we go. I do not like to work with a negative squared term. So I'm going to move everything that direction, which would mean I have m squared minus 10m minus 5 equals 0. I don't think anything will, nothing multiplies to negative 5 and adds to negative 10. So I'm going to use the quadratic formula. Or I could use complete the square, either one. But I think most students would just pick the quadratic formula. So I'm going to do quadratic formula. X equals negative b, negative 10 is 10, plus or minus the square root of negative 10 squared is 100, minus 4ac, and watch your signs here, all over 2a, and a is 1. X equals 10, plus or minus the square root of, that would be 100. That would be 4 times 1 doesn't do anything. Negative 4 times negative 5 is positive 20, all over 2. So that's x equals 10 plus or minus the square root of 120 over 2. Now, square root of 120 is not a perfect square. I know 10 goes into it, so it's 12 times 10. I still don't see a perfect square. But I do see that that's 4 times 3 and 2 times 5. So what I do see is that this is a perfect square. So the square root of 4, the 2 is going to come out. And then stuck under the radical are 3 times 2 times 5, which is 15 times 2, 30. All right, so this is x equals 10 plus or minus 2 root 30 all over 2. Now, since all three, 1, 2, 3, have a common factor, I can divide everything by 2. Whoops, 2 goes in there one time. And this gives me x equals 2 plus or minus 1 root 30, which is just root 30 all over 1. I don't need to write the over 1. All right, and the last one, factor g, right? 9n squared minus 64. So you can try to find something, right, that will multiply to a times c and add to b, which is 0. 9 times 64, by the way, is 576, and you might not know that negative 576, right? That's a perfect square right there. And to add to 0, but you should recognize that this is a perfect square and that this is a perfect square. This is called a difference of squares. A squared minus b squared always factors as a plus b times a minus b. So we're going to go ahead and identify a and b. So to identify a and b, we square root both of these. The square root of this, a, right, the square root of 9n squared is 3n, and the square root of 64 is 8. And so this is going to factor as 3n plus 8, 3n minus 8. Now, don't take my word for it, check it back. That's 9n squared minus 24n plus 24n minus 64. Those will cancel, and I get 9n squared minus 64. All right, and we're done with the question number 3. That was a really long one. Okay, solve the systems of equations algebraically and graphically. Okay, so